Have you ever wondered how an Amazon package magically shows up at your doorstep in just 2 days, even when it ships from thousands of miles away? Making this happen is no accident. Large companies like Amazon rely heavily on industrial automation and robotics to sort, package, and distribute millions of products to customers across the country every single day. Over the past 4 weeks, our team of mechanical engineering students at Penn State University have explored how robotic automation is used to streamline these processes. Using the Dobot Magician, we designed and implemented a fully autonomous, multi-robot system to simulate a real-world assembly line. My name is Nick Taborelli, and along with my teammates Ikmal, Haizammuri, and Erica Lee, we spent the past few weeks learning how to automate and replicate real-world manufacturing and distribution processes using robotic systems. In Lab 1, we learned the fundamentals of operating and programming the Dobot Magician robotic arm. We explored basic robotic kinematics through point-to-point motion using joint, linear, and jump movements, and practiced controlling the robot's position using X, Y, and Z rotational coordinates. We also programmed and swapped end effectors, including the suction cup and gripper, to perform automated pick and place tasks. Additionally, we integrated external hardware such as a conveyor belt and IR sensor, using I/O communication and branch logic for decision-based control. In Lab 2, we integrated machine vision with the Dobot Magician to build a vision-guided robotic system. We processed camera images, performed camera-to-robot calibration, and converted image coordinates into robot coordinates. Using color extraction, morphology, and blob analysis, the robot autonomously identified, picked, and sorted colored blocks in real time. In Lab 3, the primary focus was robot-to-robot interaction and communication using the Dobot Magician. We learned how to coordinate two robots through handshaking and I/O communication, allowing one robot to signal and another to perform actions safely and sequentially. Using this approach, one robot delivered a part while the second Dobot received the signal, moving along the sliding rail and completed the pickup task without collision.
Our project demonstrates an automated packaging and sorting system using two collaborative robot arms. The goal is to show how multiple robotic stations can work together to complete a task autonomously. Robot A acts as the sender. Using an overhead camera, it identifies colored objects, places them into matching boxes, adds lids, and transfers the boxes onto a conveyor belt. The conveyor belt moves the boxes into Robot B workspace. Robot B receives the boxes and sorts the objects into colored coded bins, completing the automated workflow. Here, color extraction is used to classify objects before sorting. An overhead camera captures the workspace, and image processing isolates each object based on its color. Once detected, the object's position and color classification are used to guide the robot, allowing it to pick up and place the object into the correct bin autonomously.
The sending team used the color matching technique to sort 4 different colored coins into their respective boxes. Using the suction cup end effector, they successfully color matched each red, green, blue, and yellow coins to the boxes and closed the lids to their box before sending the gifts to us on the conveyor belt. In order for us, as the receiver, to begin our operation, we had a breadboard set up where an LED light would light up, signaling the end of the sender's operation and the start of ours. We unfortunately did not have enough time to test both of our operations in one go, but when we individually tested, it worked. So once the 4 boxes were placed on the conveyor belt, we as the receiver would take the boxes off the conveyor belt and into our workspace. Our Dobot arm moves out of the way of the camera and takes the lid off our trash bin. We've designated the yellow box to go to the trash. Meanwhile, with our robot arm off to the side, our camera is able to take a single picture of the boxes in view, and our color matching and box sorting operation is able to go. After adjusting our exposure and RGB values for each color, we were able to successfully and smoothly color match and sort all 4 boxes that we received from the other team.
In this final project, we were able to work with another team and use the skills we learned over the first 3 labs that helped us successfully mimic a packaging and assembly line. Our success criteria heavily depended on no human intervention at any stage of the operation, and both our teams were able to achieve that. Thank you!